morning, fancy meat computers. How is everybody doing today? Hopefully you're doing okay. This is the right stream, right? We've got some viewers. So, I'd like to apologize, first of all, for having to postpone yesterday's lecture. Yeah. How am I doing? Not any worse than usual, that's something. That's good. Not worse than usual is good. Yeah, I'm doing okay. Yeah, so... Yeah, I apologize for having to postpone the class on such short notice. There was kind of like... I don't want to get into the details of it, but like there was a... something of a, like... I guess you would call it a mild medical emergency. It's like, you know... My wife, Allie, she's fine, so please don't worry, but, you know... It was like a sufficiently serious thing for us to have to address it immediately. So, you know. Anyway. So that's all good. But that does sort of leave us with the problem of having to schedule a makeup session. And I was, you know, it seems to me, since the makeup session will be occurring online and, you know, people who don't view the lectures concurrently anyway, like hypothetically have no horse in the race when it comes to when the makeup session should be, I was thinking that I would just ask you fine folks when the most convenient time would be to have that makeup session, because, you know, as the people who actually come to lecture, you're the people who hypothetically have the, you know, you have the, you know, you're the people who count, basically. How does Wednesday sound? Wednesday, what time? Well, so here. I'll write down a couple... if you guys would propose a few options, I'll do a poll, and then we'll see which of those options is the most popular, and then we'll go with that. How's that sound? So, I don't think Saturday at 8 a.m. is going to be very popular. So, let's see here. So, Wednesday 10:30 I could do. Wednesday at 12:30 I can't do. I've got another lecture at that time. Wednesday at 4:20 I can't do that. I've got a guy coming to the house. Can we make a poll? Yeah, I have to get the options for the poll first. Thursday at 4:30. 4:30. Yeah, that's something I wouldn't have a conflict with. I'd have to leave office hours a little early, but, yeah. Wednesday evening. So evening, what are you thinking, like 7, 8 o'clock? Something like that? Thursday one, Wednesday. Okay. I'll just say, like, Wednesday at 7:30. Yeah. So, I know, like, unfortunately there's gonna be no perfect solution to this, but, I think we've got 3 options, so let's go for it. Makeup session? Sesh? There we go. That's how the kids speak these days. Hello, fellow young people. Wednesday at 10:30. Thursday Wednesday at 4:30. Yeah, like 7:30 p.m. in the evening. Wednesday at 7:30 p.m. And then, just for fun, Saturday at 8 a.m. And we'll see where the results come in. I feel like playing the It's Time to Vote music from, like, America's Funniest Home Videos. Give it another minute. Oh. I think we need Kahoot music. Yeah! Kahoot. My god. Is that 10:30 a.m. on Wednesday? Yes, that's 10:30 a.m. on Wednesday. I wouldn't have it at 10:30 at night. That just... Man. Just keep the baby up. So, I think everybody, as many people as possible have voted. Possibly. Okay. I'm going to end the poll there. I have one more vote than I have concurrent viewers. So, one more vote than concurrent viewers. So I think that that's probably everyone. So, by a margin of, let's see. Come on, poll. Show up, please. There we go. So, by a margin of 25 points, the overwhelming majority of the population in this class wishes for the makeup session to be tomorrow at 10:30 in the morning, which is basically this time slot, but one day later. So let it be written, so let it be done. Not even the guy who proposed Saturday at 8 a.m. voted for it. Oh, yeah. So let it be written, so let it be done. Again, I apologize for the inconvenience, and yeah. Yeah. Anyway, so, shall we do some lecturing then? Shall we learn some stuff? That would be good, I think. So we just talked about trees and how trees work. Trees being a reasonable extension of the linked lists. No, I didn't get time to fix the sum there, but don't even get me started on the week I've had. But anyway, so let's talk. We just have a few more topics to sort of clean up about trees, and then we'll be on to our next topic. So let's clean these topics up. So essentially, this summing algorithm is an example of it's a particular instance of a class of algorithms that we call the depth-first search. When did I say the makeup lecture is again? I was talking to my roommate. It's tomorrow at 10:30, according to the poll. Yay! So, essentially, there's depth-first search, and then there's breadth-first search. depth first search is where when you're performing a search over a tree, you go down a branch until it's not possible to go down that branch any further. You backtrack to the first node that you find while backtracking that has a branch you didn't explore. Then you explore that branch, and by doing that, you sort of explore all of the possibilities in the tree, going by the depth first search. So yes, depth first search selects a branch and follows it until the leaf node is found. If a leaf is reached without the searched for item being found, depth first search backtracks to the last node it made a branch decision on with untried branches and tries another branch. Suitable for exploring decision branches in game AI. So depth first search has a number of applications. Like if you're doing like a chess algorithm, this is one of the ones that you would do. So that's depth first search. When it says make a decision about which branch to follow, normally that decision is very, very simple and arbitrary. It's something like always try the left branch, and if the left branch, like if the right branch is untried but the left branch is, try the right branch. Like normally it's very, very simple. There's nothing to it, you know? It's just like always do the left. That's the level of complexity you need here. Like always do the left, always do the right, something like that. So with breadth first search, breadth first search searches all of the nodes in one level of the tree before moving on to the next. This requires more traversal and bookkeeping than depth first search, but finds the minimum branch depth faster than in depth first search. Depth first search versus breadth first search is a popular topic among people who think computer algorithms have applications to human behavior. Getting that breadth. Yes. Like these guns. Am I right? That's some breadth. Ha ha ha. Anyway. So. Actually, I was watching YouTube videos, like the other day, and I happened upon a YouTube video that actually is a very interesting exploration of the concept of breadth first search. Let me see if I can find it very quickly. It was from Computer File. And it was like, yeah, here it is. I'm pretty sure I can't play this on a live stream, but I can at least show you the video, or show you the name of the video. And if you are interested, you please watch this video. So the lightning number algorithm, basically it generates a maze, and like the path through that maze, which sort of the path through the maze that finds the first like path. Sorry, pardon me. So the algorithm searches all possible paths in breadth first search, and the first one that it finds is therefore like the shortest path through the maze to the bottom of the maze, and that's in theory that models how lightning strikes. But yeah. So I recommend that video. Maybe I'll pin it. Maybe I'll post it to the Avenue or something. Yeah. Can we put it up on the projector? Yeah. Maybe. Anyway, so there's just one more thing that we have to talk about, really. Both depth first and breadth first searches assume nothing about the structure of the data contained within the tree, aside from the fact that it is, in fact, a tree. And there's, don't get me wrong, there's a huge number of applicable situations where the tree is basically unstructured other than the fact that it's a tree. However, if we give the tree certain mathematical properties, we can write algorithms that vastly improve general case runtimes. So, let's assume we impose the following property over our trees. This is called the binary search tree property. So, if a node, which has a value x, has a left child node, the value of that node is less than or equal to the value of the parent node. And if the node has a right child mode, the value of that node is greater than the parent node. So basically, what we've done is we've introduced a mathematical ordering property. So depending on who writes the definition, duplicate elements are sometimes disallowed, and depending on who writes the definition, sometimes it's like the right is greater than or equal to and the left is less than. But the point is that like the equal to case has to be on one side or the other. So, pros. The best case runtime for search, insertion, and deletion of operations is big O of D, where D is the depth of the tree. In the best case scenario, the depth of the tree is log base 2 of n, where n is the number of nodes. However, it requires a certain amount of maintenance. My thumb is bleeding. Weird. It requires a certain amount of maintenance in order to maintain sort of the evenness of the tree. One of the things about breadth first search is that, like, in the worst case scenario, it constructs a tree which is actually a list because, like, you construct the nodes in the tree in the order that they are ordered. Like the tree, like breadth first, a binary search tree is best constructed. The more random the numbers are, the better the tree turns out. The more ordered the numbers are, the more the tree has like long branches in it that start to resemble lists. So, yeah. Cons. The worst case scenario for D is n. This is a tree with only one branch, basically a linked list. The search tree, so the search tree property is maintained, which requires some extra bookkeeping. So yeah, so it takes a little bit longer to interact with a binary search tree, but the binary search tree can produce very good runtimes. Like, in general, whenever you have a logarithmic time algorithm, that's like super hyper good algorithm territory in terms of runtime. To address the drawbacks of unbalanced trees, binary search trees in practice often use balancing algorithms, such as red-black trees or the Adelson-Velsky and Landis tree. But we're not going to talk about those. So, any questions? If not, we will move on to our next topic. We're actually swiftly drawing to the close of the C material. We're going to be talking about what's it called? Assembly programming. We're going to be talking about assembly programming soon. Somebody knows. Somebody knows that assembly isn't a whole lot of fun. This is a short topic, by the way. Does this mean we've become programmers? No. No, you have to have done this one first. You have to learn about preprocessor directives. So this is, like, as you can see, this is a very short topic. But, should you be scared of assembly? Yes. So, topic 9. Subpar grammar. Oh my god. I have to write that. Oh my god. Okay. That's okay. I'm stealing your chat for a meme. I'm stealing that. That's good. That's some comedy gold right there. Like, I'm actually going to write that down. Let's see. Pro-grammar and subpar Programmer. Perfect. Thank you. My friends are doing assembly in their computer science programs, and they told me if you think C is annoying, assembly is 100 times worse. Yeah, you really have to rein in your expectations with what's possible. Yeah, you really do steal as you please. Thank you! So, yeah, it's like, yeah. No, that's like perfect meme material right there. Half the probably at least half the memes that I post to the channel are stolen. So, yeah. So not to dwell too much on assembly because we haven't quite gotten there yet, and we should really talk about assembly when we're talking about assembly, you know. But yeah, it's like it takes the same amount of time to program the equivalent of maybe like 3, 4, or 5 lines of C takes you as long as doing like one of the C problems that you currently do. Like, not like the super long one, like question 3 from assignment 4, but like, you know, like a moderate C program, like bubble sort or something, or insertion sort, like that level of the question. That's like to do like that amount of work in assembly only gets you like 3 or 4 lines of C code, if that. So that being said, the operations themselves are actually like extremely simple. It's just a matter of understanding how it works. But anyway, so let's talk about the C preprocessor and miscellaneous appendices. We will talk about appendix miscellany. So, let's talk about preprocessor directives. So what's left? We've talked a lot about C. What's left there? What is left for us to talk about? Not much, as it turns out. We need to go over some of the advanced preprocessor commands. But like once we're done with that, it's like I'll teach you how to take input and output from terminal, and then we'll talk about signals, and then it's like, yeah. So we've talked about define before. We'll go over it again because you probably forgot because we covered that in like week 3. So define, undefine, if and end if, error, pragma, and line. So the C preprocessor is responsible for handling all of the operations that need to occur before a file can be tokenized, an abstract syntax tree produced, and the executable generated. So once again, preprocessing is the step in the compiler that prepares the file for parsing. So some of the things that you get for free with preprocessing that you don't have to like do an explicit command for are removal of comments. Actually, removal of white space as well, but you know, we generally don't even think about white space. But yeah, the comments have to be removed before the file is processed, obviously, because they're not valid code. And all of these preprocessor directives are processed before the file is even parsed. So, for example, the define pragma is an operation over the file, not an operation over the program, right? It's like string manipulations. You're manipulating the string of which the program itself is composed, rather than manipulating the program. Well, I mean, you are manipulating the program, but only insofar as as modifying the text of the file itself modifies the program. So, a preprocessor directive is some manipulation of the text of the source file. So, at the beginning of the course, we explained how macros can set symbolic constants, but they can do much more. We can do much more with them than just specifying the size of an array. So, just to remind you of the syntax, we can define some identifier with some replacement text. Remember that a macro is a character substitution operation. This means that a macro may be used to insert anything into a C file, including, but not limited to, semicolons, curly braces, complete or partial expressions, assignments, argument lists, and function calls. So, the stuff that you can put in the replacement text is anything. anything at all that comprises valid C code. Macros have no grammatical limitations, though the substitutions they make must result in grammatically correct C code, or else the thing won't compile, obviously. It's recommended to keep these substitutions to one line, otherwise things get messy, and macros are named in all caps by convention. So, for example, if we define a bunch of macros, right? So we define begin as being empty round braces and an open curly brace. Twice is x. So twice takes a parameter x and prints it twice. Prints it in the file itself, right? Int print, taking parameter x, is print. So that'll replace it with printf, and then like printing it as an integer, and then putting x in there. And area xy is just x times y. So so we can say int main begin. If 1 is equal to 1, then int print area 8, 10, and then twice close curly brace. So this allows you to perform the same types of abstractions that you performed over variables on the syntax of the programming language itself. The problem, of course, is that you can make things very unreadable very quickly by doing this. So, you may have noticed the program on the previous slide contained macros with function-like construction. Yes, you can make your macros contain arguments. You can make your macros take arguments, pardon me. The process somewhat resembles lambdas in Python, which I'm not sure you guys probably never did lambdas in Python, but you know, it is what it is. If you know what a lambda is, then you'll know what that means. The main difference, of course, is that we are performing character substitutions only. So the arguments to a pragma may be any group of characters so long as the operation results in valid C code. For example, the macro twice x, xx takes the input x and inserts 2 of them into the file, where x can be any character, right? I don't understand why there was 2 x's in twice and why there was only an empty space between them. Like, what does twice do? That's a good question. So I'll just I'll manually perform. So here's what we'll do. Text selection. Copy text. I'll just manually expand these for you. Oh. I'll just manually expand these for you, and that will, like, I know this is a garbage mess, but there. So this is, believe it or not, this is a valid program with the macros as defined on the slides. So, begin. So this is what the preprocessor will do. It hits the tag begin, and it's like, oh, this is a macro. I'll just insert that, right? So we then hit int print. The underscore was removed for some reason. So that replaces whatever is in here. So it calls this x, right? And replaces it with printf the new line, comma, and then whatever x was, it takes this guy, places him in here, and there you go. Ta-da! Technically, actually, I think this is incorrect because it duplicates this guy. But anyway, area does a very similar thing. So area gets replaced with this guy. First argument goes here. Second argument goes here, and that gets deleted. So there you go. Oh, I deleted one too many. There we go. And finally, the one that you're all waiting for, twice. So twice is like, okay, I'm inserting x and x with x equal to this character. So replace, replace, and get rid of the tag. So that's what this program looks like once all the macros have been expanded. Yeah. So there you go. My one problem with macros is that it is more effort to get the macro working than the effort it saves. Yes, so, yeah. But you still have to, like, I still have to cover it, right? Like, just because it's not the most efficient way of coding doesn't mean that it's not, like, basically, in C, macros are often used to set, like, global constants. Like, there's a number of things that are defined as macros inside of, like, the standard libraries and such. Like null, I believe null is defined as a macro. So, you know, so as a preprocessor step, null is replaced with 0 everywhere you use null inside of your program. But yeah, so you should know how they work, and you know they are occasionally useful. But yeah, one of the better uses of macros that we're going to see is that you can actually set up your program to have a debug mode, and like you can pass a flag into the compiler, compile it in debug mode, and that like turns on all your print statements if you set it up correctly, and like your print statements get turned off if your compiler doesn't have the flag. Like there are useful things that you can use them for. Is it more memory efficient to define a constant with a macro than it is a variable? Yes, because a macro isn't stored, right? Like macros are never stored in the program. Like as the program's running, a macro doesn't even exist. Like it's just a compiler entity. So yeah, you don't have to set memory to hold on to a constant value. It just makes that syntactic replacement. So if you apply that to an embedded systems context, very often how embedded systems work is you compile the program on your computer, and then you load the compiled program onto the embedded system. Like the embedded system would not ever be responsible. Like only in rare instances would an embedded system be responsible for compiling its own code. You would just be flashing a program to it, right? Like, it depends on how big the embedded system is. If it's like one of these bigger, like, ARM architecture guys that runs like a tiny Unix or Linux distribution on top of it, then obviously it's going to have GCC. But if it's like a proper little PIC microcontroller or like an Atmel or a, like a little Arduino board or something like that, you compile it on your computer, and then you load the compiled program onto the microcontroller. So anything you can load into the, like anything you can front load in compilation is stuff that you're saving on the microcontroller itself. But yeah. Did it say in the previous slide that we could redefine these macros? Because I would assume we couldn't. Ho-ho! Well. So it's not so much that you can there's no specific redefine operation, but there is an undefined operation, and once you've undefined it, you can redefine it with another define. so it's like, there's kind of like you can get it to redefine, but you generally wouldn't. I don't see why you would. So, if you want to restrict the applicability of macros, you can use the following to remove them. So undef removes a macro definition. Remember that macros are also imported when you include a library or one of your own source files. By using undef, you can prevent macros you define in one file from being applied to another. Once a macro has been undefined, it can subsequently be redefined so that it can also be useful if you So this can also be useful if you want your macro to perform different substitutions in different parts of your source file. The above does not seem like an advisable use case, however, as it seems rather spaghetti code-like. So yeah, one of the things about like macros in general is that you should use them judiciously, because they can result in very spaghetti code-like things. And, you know, the degree to which you will get useful, like, compiler warnings might be, you know, you might not get as useful a compiler warning if you've got all kinds of defined statements going on everywhere. So, we can hide code from the compiler as well, conditionally using if and endif. So, if you've... What happens if you put two defined statements right after each other, but with the same name? For example, def begin and def begin. Will it cause an error? It might just be a redefinition, to be honest. I'd have to actually compile something, eh? Okay. Okay, I'll compile it. How does it... Is it capital or a lowercase? It's lowercase, okay. If I save this as a C file, it'll... But where? Save it as macros.c. There we go. So define begin as 1. Define begin as 2. Print begin. See what that does. Let's just get rid of this. Why is it even necessary? There we go. All right. GCC, macros. Warning! Begin redefined. Note, this is the location of the previous definition. So it gives you a warning. A.out. 2. So it just takes the second redefinition, but it gives you a warning. Whereas, I'm sure if you undef it, it won't give you the warning. Yeah, if you undef it correctly, then you don't get the warning. But yeah. So what does 2MD3 look like compared to this? I don't know. I've never taught it. That's unfortunately as simple an answer as I can give. I have not taught it, so I don't know. So good. Good. So yes. So any code between if and endif will be deleted if the condition evaluates to 0, and will be kept otherwise. The condition expression must have integral type and can only include integer constants, character constants, and the defined operator. So remember, this command is being executed before your program compiles. As such, functions, variables, enumerations, and type defs should not be used. Right? So it's like you can't use variables because to know if the this needs to be evaluatable at compile time, not at runtime, right? So so it has to use exclusively other macros to decide whether or not the code needs to be included. But again, this can be a way of like turning on and off sections of your code. Like one particular use case for this is there are some macros that define certain system constants. Like, for example, what operating system, like what distro of Linux you're using or what version number you're using. Using the the macro condition, you can sort of turn various function, like you can alternate between different definitions of various functions depending on what version number your operating system is and stuff like that. But generally speaking, at our level, there's really not a huge amount of purpose for this, unless you want to put in a debug mode, which debug modes are really useful. But yeah, the heavy side function of C. Oof. Yeah. Good. So. So, common use cases of if include preventing a header file from being included multiple times in the same project, which can be a problem. Giving a program a debug mode. Typically in debug mode, a program will execute many printf statements, which reveal internal data or generate a log file. Setting different constants or executing different statements depending on system-defined values. This could be the word size of the processor, the version number of the operating system, or any number of things. This assumes that the program will be compiled from source on multiple different systems. So if your idea is that you want to compile it once and send the executable out, right? Like, you know, a lot of, like, most programs that you receive through the internet, for example, come pre-compiled. You don't have to compile them from source. That's one way of approaching it, but that's not a scenario under which you would use this type of thing. If you expect the user to compile it on their own system, like, for example, the Linux kernel, then this is a perfectly valid way of approaching things. So, there are some quality of life improvements. There are some variants on if that can, allow you to use things a little bit more intelligently. The defined macro operator returns 1 if the macro has been defined and 0 otherwise. So you can bounce around ifs depending on whether or not macros have been defined or not. Elif and else may be used in the same way as else if and else to create additional branches. If def is shorthand for if defined. If ndef is shorthand for if not defined. And you can use if to comment out blocks of code. Using the regular block commenting doesn't allow for nesting, but if and end if do allow for nesting. So if you need nested comments, nested blocked out comments, then this is a way to do that. And so let's clean up the miscellaneous ones. Error prints an error message. What the error message says depends on your system and C's implementation. This halts compilation upon execution. So you can terminate compilation by throwing the error pragma in. So pragma performs miscellaneous commands. Which pragmas are available depends on your system and your C implementation. So there will be a slightly different set available for Linux as there are for Windows. Using pragmas may make your code less portable. And line, integer, manually changes the line number of the source file. This is generally used to generate more meaningful compiler warnings and errors. So if you want to manually manipulate, like, you know, you had an error on line 37. If you want to, like, take that 37 and, like, you know, manipulate that, this is you can do that with the line pragma or the line preprocessor directive. Any questions? What do we put int tokens? What? Oh, what do we put in tokens? Oh, that's like numbers, like error codes. So if takes it out when it's compiling. So if takes it out when it's compiling, or I not understand this right? No, you understand that correctly. So if removes statements during compilation. So something that's taken out by if is taken out and like never even doesn't make it as far as parsing, let alone generation. Yeah, I know. I know I had a spelling mistake. Les portables. Yes. Where is this mythical go-to that I mentioned? Oh, I'm not gonna teach you the dark arts twice. If you want to know about go-tos, go back to when we were talking about like switch cases. How would we use code? How would we code using the directives? Well, kind of the point is that generally you don't need to, you know? This is this is the reason I'm going through this with you right now is for completeness primarily. It's like this knowledge is for you more like not necessarily for you to use, but for like if you are reading some C file, you know, you'll know what the stuff in the C file says. I'm kind of confused why you would want to use if instead of a regular if statement. Again, because you can do things with if with the preprocessor if that you can't do with an if statement. Like with preprocessor if, you can like poof entire functions out of existence, right? You could take like 3 function definitions and just poof, you could disappear them, you know, or you know, have them appear or disappear conditionally. Yeah, let me see if I can find something. Let's see here. GCC. No, I want... There we go, this might be useful. Cat, is stdio in this? Standard bool, maybe? Yeah, there you go. So, so what I just did is I reached into my operating system and found the source for the standard Boolean header file, right? So, so you've been using this, right? But so this is what it actually looks like. So you'll notice this is like the way that Booleans have been defined inside of C is using define statements. Wah! So there you go. So this stuff is mainly used at like this level, right? I'm teaching you this so that you're not looking at this and being like, this doesn't even look like C code to me. What the heck, man? It's like, yes, it is C code. All right? It's just, it's primarily macro definitions. I just don't understand why you would want to poof them out of existence. So let's imagine you've got 2 versions of a function, right? One only works on Windows, one only works on Linux, right? Because they have to be written differently for Windows and Linux. You can set an if-def so that if the operating system is Linux, it keeps the Linux version, and if the operating system is Windows, it keeps the Windows version. That's the level of access that you have at this point. Um, could make the code file smaller so that if you don't include functions that aren't needed for the implementation. Yeah, that's another thing you can do, especially for embedded systems. So it's more for the sake of optimization. Yeah. Is the true Boolean only 1 or any integer value other than 1? Any integer value other than 1 will work. Basically, the way, like, C had Boolean functionality well before it had, like, a dedicated Boolean type, right? It's these define statements that set, like, the true and false literals inside of C, right? And give you the access to the type. It's like the way, like, standard bool, like the library has to pick one value for true to be, but if you are like casting integers as booleans, 0 is false and anything that's not 0 is true. So yeah. So Boolean has been int this whole time? Yes! Everything has been int this whole time, except for floats. Because it didn't work when comparing true to the output of is space, because that outputs any int other than 0 for the true case. It would probably work if you used and, right? Ha 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 ha! Oh ho 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 ho! That's right! Because I think Boolean and would work instead of equality. Like, if you're comparing two things to see if they're the same, then obviously that wouldn't work. But if you're comparing two things to see if they're both true, then you could use Boolean and. But yeah. But, yeah. Like, that's the thing, is, like, equality is overloaded, but it gets complicated, man. It gets complicated. Yeah. But yeah, all Booleans are integers under the hood. So, alright, so it's now 11:20. So class has officially ended. We will have our makeup class tomorrow at 10:30. So be there or be square. But if there's any further questions, I'll answer those questions. And if not, we'll get the heck out of here. Dang, I guess I gotta be a square. That's okay. Being square is fine. It's okay to not be a hippie, I guess is what I'm trying to say. Because that's a thing that hippies would say. It's like, oh man, your dad is such a square, man. It's like, yeah, okay. But I'm also not a hippie, so, you know. I'm not going to ruin my brain on acid, so that's probably a more effective life strategy than being a hippie. You know, when they had first developed acid, they like the mind-altering chemical acid, they thought that it had no side effects. I thought that about cocaine for a while as well. Did you know that the original formulation for Coca-Cola had cocaine in it? That's why it's called Coca-Cola. And did you know that Coca-Cola is still it's the only remaining it's the only remaining legal manufacturer of cocaine in the continental United States? Because cocaine, like, it's useful as like a chemical ingredient. You can manufacture certain medicines out of it if you take it as as like an ingredient to other chemical processes. So there is actually like a legally responsible use of cocaine to make medicine. So you do actually need some domestic cocaine manufacturing. But yeah. Anyway, in case you hadn't realized this by this point in the class, your professor is a huge know-it-all. Anyway, take her easy, folks. Coca-Cola and Aerosmith must be really good friends then. Yeah, because, you know, Aerosmith is from the era when Coca-Cola still had cocaine in it, right? I know that's not actually the case. I'm just making a joke about how old Aerosmith is. Hmm. Yeah. My goodness. Yeah, you know, just in case you thought that that giant evil mega corporation wasn't a giant evil mega corporation. Also, the whole thing about Santa Claus being in a red suit because of Coca-Cola is also actually authentically true. And the same artist that did the Santa Claus for Coca-Cola did the Quaker Oats guy. Like that guy, that sort of lovable, chubby, like slightly chubby guy in the weird hat on the Quaker Oats. That's the same artist. They've slimmed him down over the years, by the way. He was originally much more rotund. Anyway, take her easy, folks.